Hello everyone, my name is Joe Scorsone, channel is called Ethernet, and in today's video we are on episode 16 of the Quant Finance Advent to Code. This is probably going to be the last video, I think, about the parallel backtester. Even when we do stuff like machine learning, I'll just leave it to you guys to put it in there because we're going to be doing the machine learning from scratch. So I would honestly leave it to you guys to use a library after that, but do it from scratch at first. We got to code more stuff from scratch. It's fun. I think it's fun. Regardless though, this is episode 16, so we're going to hop right into it. This is my X account. You'll get every update on here first if you follow it. Also make sure to like and subscribe on the channel if you're enjoying this series. We're on episode 16 now. If you guys like to actively trade, then my algorithm with Lux Algo might be a good tool for you. There is more information about this on my channel and in the description. So now let's hop into our task. So we're going to modify last video's code by allocating weights based on risk parity. And we're going to modify SPY to be a her strategy. We're going to plot the results with the risk parity weights. Cool. So let's head down to the bottom, because SPY is now the strategy. I couldn't get it to work with the none strategy, the outright hold, being represented in the risk parity. And I figured it's water under the bridge. I figured it was all right. I figured I could overlook that just for this video, right? It would still work. You wouldn't get an error, but this would not be affected at all, and it would only allocate based on Microsoft and Square, is what it is. But yeah, let's actually go through and see the changes to do risk parity. And what is risk parity, right? So I have this dictionary up here for each ticker and the risk parity weight. I just made it local to the whole class, so that way I don't have to worry about passing it around. And so yeah, what is risk parity? So now let's actually look at the function first. So optimize risk parity. We're going to initialize everything just by inversing the volatility, or just using basic standard deviation for this volatility. And this actually is fine because of the weights need to sum to 1. So it makes sense. It's fine to have this constraint on it. You're not going to get that close anyway, so might as well just have that ease of use. And this isn't the make or break in something, right? So you could cheat. So this is our function to minimize. This is our objective, because this is the overall risk of the portfolio. And this is how much each ticker is contributing to the risk. And so we want to get the risk contributance minus the average squared. That is our error. We want to minimize that. And these are just constraints and bound to sum to 1 and then get the result by minimizing that. But why do we want to minimize that? That's because some tickers might impact the overall volatility of the portfolio less than others. So those are the ones that we want to allocate more to. Not necessarily because we think that they're going to return more, but because their volatility, they will bring, allocating less to them will lower the overall volatility of the portfolio, which is the objective. The objective isn't to maximize profit, it's to lower volatility. That's why we're minimizing this function, which is a function of volatility. So we're just going to start with these initial weights, which is just inverse volatility. And yeah, because remember, we're using our data dictionary. So our returns, we're using our data dictionary, so we have each ticker and everything else in there as well. We're working with just one block. So you might see an issue here. You might see an issue here because this is just one calculation, right? There's no looping, there's no linearity in the looping like in the Hurst exponent or in adding a strategy. Isn't there some look-ahead bias here? We're using this entire data frame, right? We're using this entire dictionary. Isn't there some look-ahead bias here? Well, no, there isn't, because of our simulate portfolio. There isn't because I caught it because I was looking at it and I was like, something don't feel right. So in our simulate portfolio method, in our for loop, when we start iterating through our daily returns, once I is greater than 2, we're going to avoid look ahead by only passing the data up to I to do the risk parity on. So that way we can make a decision with only the most present information. We're not using data at the end of it in the beginning. We're only, right? I can never do this right, but we're only using information and then we're slowly going forward as we enter in positions. So it is dynamically allocated. It's not constant. but it ends up being pretty close to the constant. So if we were to run this, we're going to get some output. And the weights that we are going to get, when I had the code wrong outside of the for loop, it was pretty damn similar. But it's still, that's not the point. The point is that you need to be able to spot these things, you need to be able to look at them, and you need to know when they might sneak up on you. So let's get our first one here. Reminder, this isn't going to have the outright hold, so it is going to be a bit more aggressive. So here we go. I'll move my face down. Oh gosh. So here we go. So SPY 55 and that, Square 14 and change, Microsoft pretty much, Microsoft is 30 and change. So you'll notice that Microsoft and Square pretty much inversed their weights. And we got a pretty damn good return. So we'll let the other ones come in and then we'll talk about it in more detail because I hate getting cut off like that. But yeah, still the same stress testing. But yeah, I just think it's really interesting how, and I also like how it'll adjust with the volatility, right? Not by much, but by a little bit. And it adjusted it to SPY, which is nice, not like Square or something like that, which would definitely have more volatility. So here we go. This is all of our backtests, right? So we have our first two backtests here, which is, of course, close to a double. It's better than the other ones because SPY is actually being actively traded. And it also has, and we're also allocating weights correctly, right? Who would have thought we should allocate more to Microsoft? Not me, right? So that is what this method can do for you. Because it's a simple add, right? It didn't take me that long to add it, but it is very helpful. And it also, in our crash, it actually does allocate more to Square because Square is a mean reversion strategy. So when it goes down, Square will hold up better, which I think is just so cool. This is the shit that gets me giddy. But yeah, that's pretty much all to add risk parity to our backtester. You just have to ensure you don't fall victim to look ahead bias and ensure that you're using a strategy that can be represented by. Again, I think it's water under the bridge to not have it on the outright hold. But because at the end of the day, what you could really do if you really didn't want to have it, didn't want to have it, I'm sure that you would be able to skew it in some ways to only have it represent one strategy a little bit so that way you can just manually add on the return of the outright hold over how much you would actually have to put in it. Regardless, that's just totally separate conversation and redundant, I think. But yeah, guys, I hope that you guys are enjoying the series. Hope that you guys subscribe to the channel and enjoy more stuff from me. We're going to be getting into machine learning and all that stuff pretty soon. All of this is going to be done from scratch, so I'm probably not going to be adding it to this. But of course, this is all open source. This is all on the GitHub, so you guys can definitely add it all to that yourself. So yeah, that's the video. I hope that you guys all enjoyed it. Hope that you guys stick around for the end of the series. And yeah, I'll catch you guys in the next one. Goodbye.